Hey, thank you for joining us. This is week 8 of our Wolff Weekly live stream. So thank you for being here. Thank you for joining us. This has been, 8 weeks now. We've been doing this for 2 months. It doesn't feel like we've been doing it that long. But thank you for joining us and interacting with us, joining the comments, letting us know where you're watching from around the world. We really appreciate it. This is the last of our weekly live streams. We are going to continue this format. We're going to continue doing this, but we're going to go to a monthly format. And that's just because, at least here in the U.S. where we are, things are starting to open up a little bit more. Businesses are starting to open up. Salons are opening back up. And hopefully business is starting to roll more, and we are starting to kind of come out of our quarantine. And so we did this weekly format because a lot of us are unable to get out and travel and all that, and so we wanted to support the industry in that way. And so we've really enjoyed doing this, and we've been getting really good feedback, so we want to continue doing it. But the way we're going to be doing that is on a monthly format, and we will talk more about that at the end. So want to introduce myself. I know y'all have seen me all 8 weeks now, but my name is Caleb, and I do sales and marketing here at Wolff Industries. And once again, we've got Glen with us. He is our master trainer here. So if you take the class, come in to do some hands-on training, you're going to be taking it here with Glen. Today we're going to kind of do some comparing and contrasting to our convexing that we did last week. Last week we did convexing on the Okami Gold with standard clamp, convexing clamp. And so now we're going to look at convexing on the Hira-To a little bit, and then also doing some scissors that are a little different that you'll run across that can kind of throw some speed bumps at you. Long curved groomers, some thinning shears, that kind of stuff. I'm going to jump back behind the cameras again like we did last time because we've got our macro shot again to kind of show the thinners. Because specifically for Tim Mansfield, last time you requested that we look a little bit more at the ramp on the thinners. We touched that a couple weeks ago. So yes, Tim, we're gonna look at how you restore the ramp, how to look at some ramps that are bad or poor ramps and how to fix it. And Glen's gonna go into all that. So I'm not gonna spoil the fun there, but let us know in the comments where you're from. I've got my phone on me, so I'll be looking for comments as we go. Dan will also be looking for questions, and I believe we may have, yes, Bill Pierce is in. He'll be able to provide some extra context and stuff to the questions that we may miss. So let us know where you're from. Marcus in Sweden, that's awesome. Thank you. Tim Mansfield, ramp on the thinners, that's for you.
Excellent.
Eileen, hey, and John. Yeah, John Soltis, you're here with us each week. Awesome. So thank you guys for joining us. We're going to get started.
All right.
Cool.
Let's go. Again, thank you. I have guys that I talk to on a weekly basis, and things have been starting to ramp up a little bit more, and I'm glad for y'all. It's hard not wanting to, not being able to get out there and service your customers, but hopefully these weekly sessions have been helpful to you and profitable to your business. A question came in because we showed the convexing on the Okami Gold using the standard clamp and the convexing clamp. They said, what's the difference between that and convexing on the Hira-To? I'm going to do just a real quick demo on convexing. This just happens to be the solid blade of a pair of thinners that we're going to be looking at here later. But it's very simple. The clamp fixture is going to stop me from extending over my cutting edge. I will do a scratch test. I like using a little bit of Sharpie. Just a little bit at the entry. keep it down around 3, which you could say is about 30% of speed. I've got my clamp set at 45 right now. Just a light touch. And I'm going to do another light touch. There we go. Looks like it might be closer to 50. Now, the abrasive that you start with is going to depend on how much damage you have to remove. I've got a 30 on there just for example's sake. If I was to look at this in a salon, I'd probably start at the 15. There's just not that much damage, but it's not used either. So when I'm going to sharpen, this is a 30 micron. I'm going to start right about 50% speed. Now, when I instruct somebody, I start away from my cutting edge and come down to my cutting edge. Okay, there are sharpeners that say once you find your angle, or trainers that say once you find your angle, get your burr up, and they'll start right on the burr. Right on the edge, and they'll bring a burr up, and then they'll convex. In my mind, that's like creating a bevel, and then you got to clean that bevel up. I like sharpening. I like using the machine as if I don't have this in the fixture. If somebody's going to train you to sharpen freehand, you start away from the cutting edge. Is my hand in the way there? Okay. You start away from the cutting edge and come down until you see a burr start to form. So you'll be coming down to your cutting edge, and the way I describe it is you just pop off of the cutting edge. But once that burr starts to come up, I sharpen in 3 sections: entry, center, and tip. I also try to keep as much of the blade on the plate as possible to blend my convex in, to blend my sharpening in. So when I'm sharpening, I'm going to get my burr started right here. My light is going to be situated so that when I slightly lift my blade up, there's a shadow underneath my edge. And that shadow is going to provide a contrast between my burr. And I don't know if we can get focused up any tighter with this, can we? With the top? Okay. That shadow is going to provide a contrast between the burr and my plate. Once I have a burr, now I've got my burr this far, and all I'm doing is, and I'm going to do this in an exaggerated manner, I'm just going to lift a little tiny bit so that now I'm going to work here. I worked here, now I'm going to work here. And all it's going to take is just a little tiny bit of elevation in the back of the arm. Once the burr is in the middle, I'm just going to elevate a little tiny bit more until my burr is all the way to the tip. Then I like to just make sure my convex is all blended in, and you don't have to go fast. I mean, some trainers will say you got to use your wrist. I like using my thumb. It's just where you have the most control, but I use both of my thumbs. Light pressure, but I like keeping the whole blade over the plate. I don't like coming out, because if I just happen to spend more time here, that's going to give me a funny shape to my, I might change the profile of my cutting edge. So try and keep as much blade on the plate as possible. Once I have a burr up, I know I've sharpened. I'll check my convex then. I like it. Now I'm going to change to my 15. If you notice, I keep center point marked on my plates, and that's going to come into play when we're working with longer dog grooming shears, which we're going to cover. With my 15 micron, I like to go up to 6 or 7. Now my burr says my sharpening is done, so now I'm just working on the cosmetics of the shear.
Glen, we got a question.
Go ahead.
From Tim. Is that a straight blade, or is there a slight bend in it from entry to tip?
No, this is a straight blade. It's, again, from one of the thinners that we're going to be looking at. I will be working with a semi-convex curved dog grooming shear in a little bit. But yeah, this is a straight blade right now. My 9 micron is my pre-polish. I can go up 8 or 9. I also like to pull the burr down. All I'm doing is lapping the burr off. So when I get to my whetstone, I had a gentleman question the accuracy of the blade moving left and right on the plate, and it's on the same plane. So it really doesn't matter if I'm sharpening here, where it's staying in one spot, or if I'm over here sharpening, I'm still on the same plane. That's my plate. Go ahead.
Eileen asked if lifting the handle up, does that change the cutting edge?
If you see, Eileen, the profile of this cutting edge, okay, there's an arc to it. In certain small circles, and I've seen it a lot on the internet that says this is an 800 millimeter radius. Well, maybe one particular manufacturer uses that 800 millimeter radius, but not every single shear has an 800 millimeter radius. By lifting, what I'm doing is I'm following the radius that's on the shear. So I am just following the burr. When I see a burr appear, I'm just going to lift up a little tiny bit, and I'm going to be working on another area of the blade. And I'm following the profile of that cutting edge. Now, if that doesn't make sense, we can go over it a little bit more detail. Let me know in your comments, okay? But all I'm doing is following what is there on the shear. Whether it's, there is no way this blade has an 800 millimeter radius. And this one. Because they're two different arc profiles. So it's not an industry standard, not even close. So don't worry about the 800 millimeter radius. Follow what's there, okay? Now, that's the sharpening process. From here, we'd work the inside line on whetstone. That's what comes with the Hira-To. And then we'd come back, put it back in, and polish it out on the polishing plate. But that's the process for a convex shear. Now, we're going to go, and I'm going to show you a curved grooming shear. This is the longest blade I could find. It has a 6.5 inch, 6 3/4 inch cutting edge. So I think in some industries it's called a Filipino blade. But you can see it goes far past even the other side of the plate. So obviously I'm going to have to be pulling out, and I'm going to have to take care that I don't spend too much time in one particular area, and I have to make sure I'm not coming, and I don't know if you guys can see, I want to make sure that I'm not creating a notch here in the entry by having my tip too high. Okay, I want as much as this blade on my plate all the time. But because of the length, and I don't want to touch the plate past center, I am going to be pulling out. The tip, you have to be careful that you don't raise too high. Can you see this gap in here?
Yeah.
All right. I want to make sure I'm not lifting too high. I want to try and keep as much of the blade on the plate and still touch the tip to your plate. All right. Now this is just an example. I have sharpened this particular blade for another purpose in my training. So I'm going to switch over to this shorter semi-convex. We dealt with curved shears in another video, so I'm going to reiterate. When these shears are made, they are finished with the blade straight. Once they're finished, then they're curved. Set is adjusted to make sure that they cut properly, but the convex or the semi-convex, the inside line, all of this work is done while the blade is straight. Then they put it in a machine that adds set to it. So what the sharpener is doing out in the field is something the factory really hasn't had to do. They may have to, put a final polish on that edge. I haven't seen that process as far as an industrial or a semi-convex shear is concerned, but I know what we have to do here. When we curve shears, they come in straight, we sharpen them straight, then we curve them. If there's any kind of light finish work we have to do, then we can do that when it's curved. But typically we don't have to. I'm going to put a small mark so I know that I'm dealing with the correct angles here. Slow this down a bit. Now I'm at 50. I'm going to move this back to 45.
Bring that forward just a little bit to show.
Move this to 45. Are you able to see that? Okay. That's what it is, 45. So I'm going to start my entry, and I'm going to move my light down to try and cause some shadow or contrast. So right now, this much of the blade is touching my plate. And I'm going to pull out until my tip passes center. And I'm going to use the center of my plate to sharpen the tip. I don't have to pull all the way out here. I've got this much of my plate to use. The tip, when you sharpen out of the center of your plate, it's not going to create as much heat. And that's where I like my tip to be, because I can spend a lot of time there and not heat my tip up. Again, I have this much of my blade on that plate. I don't want to lift up this way, because then I'm going to change that profile of my cutting edge. And if I do that too much, then my tips are going to, when my shear closes, my tips are going to be ground out this way. Okay? Now, a question came to me last week. What if it's curved? I mean, not curved, but what if it's convex? A true convex curved shear. I have seen very, 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 very few of them. The greatest majority of your dog grooming shears are going to be semi-convex or polished bevel. If it's convex, you're just going to have to spend a lot of time working that convex in. Okay? It's going to be very tedious. The great majority of them are semi-convex, like the colored shear. These are all a polished bevel. So
Glenn, we got a question. Can you show the curve side that curves into?
yes, we're going to come into that. I don't have to go through all 3 plates with this, so you get the idea. Okay. Now the blade, the blade that curves towards the plate. This is the thumb blade to that shear I was just working on. Now, there's your problem. How do you get that flat on the plate? Well, there's my center right there. I have to make sure that the tip of the shear doesn't hit on the opposite side of center. So I'm going to be watching the tip very close. I also don't want to start this way, because again, I'm going to create a very evident hook or a notch in this particular shear. So I want the blade to be as flat as possible without touching the tip. One of the ways that, if I haven't sharpened a curved semi-convex before, or I mean in quite a while, I'll touch my tip with my index finger. My plate's not going to be spinning that fast. And it keeps my tip off without being too high. So I actually can lightly touch the plate and the tip of the shear. Now I've got this much of the blade on the plate. Again, make sure your tip isn't too high off. So watch the tip. Once the blade is on the plate, I just watch the tip. Can we try killing the fluorescence and see if we can get a good shadow underneath? All right, you can see the shadow of my blade right here. Okay. Now it's touching. My tip is. You don't need a special sharpening plate for doing curve shears. You can use a plain disc that you use for all your sharpening. You don't need something that's only going to have this much abrasive. Because when you're sharpening the blade that curves away from your plate, you can absolutely use the inside of the rest of the plate out that you're not going to be using with the other blade that curves towards your plate. But make sure that when you're sharpening, you don't have the tip real high. And when it comes on, when the tip and the greatest majority of the tip can touch the plate, you don't have to come all the way out. That's just going to create more heat in the tip of the shear. Once the burr is formed, you can go to the rest of we're ready. You can use the rest of the abrasives, do your finish, work the inside line. We covered working inside line with the pink hone or white hone, and polish, reassemble, test cut. And that's curved grooming shears. Convex, semi-convex, sharpening standard bevel shears, slightly different process. I like using the 80, 60, and 30 instead of the 30, 15, and 9. This particular straight shear has corrugation on one blade. If you can put the corrugation back on, great, you can sharpen it off if you have to. If you can't put that corrugation back on, I'd be very, very cautious about removing it. Work your inside line with the white, the inside of the shear. It doesn't have an inside line, but you're going to clean up any kind of nicks or damage with your pink hone or white hone, then sharpen your thumb blade. Is there another question?
Oh no, you're good.
Okay. I saw your hand go up, and but with my 80, I'm going to start at 35 degrees. Use the Sharpie. Scratch test. All right, this is 35. Now, I knew it was going to be 35 because this shear does not leave the classroom. Again, see how far past center I am. I want as much of the blade on the plate without touching my tip. Having my light off to the side like this helps me see what's touching the plate. Otherwise, you can actually sharpen with the machine tipped over all the way. We can't see with the camera by doing that. But having my light low like this helps me to make sure that I actually get my tip to the plate without having to pick it up and check it every single time. From there, from the 80, I'm going to go to the 60, speed my machine up about 40 or 50%. Then I can go to a 30, or I can leave it at the 60, wherever you want to, whether you need a little more bite, or if you want to have a little finer finish on the cutting edge. Lap the burr off a little bit so you don't have to cut off as much. Now, I would have worked the opposite blade with the pink hone or white hone. From there, I would simply cut the burr off. And then you're ready to sharpen the second blade, if it's not corrugated. Curved semi-convex, or I'm sorry, curved standard bevel shears. I'm going to start with the thumb blade. This particular blade is the one that curves towards the plate. I'm going to do my scratch test. Make sure we're doing it right. Watch the tip. Looks pretty good. Speed up to about 40%. Again, what I'm doing is I'm making sure my entry is lined up with the outside of the plate. Then I see where my tip is.
Got a question.
Go ahead.
Can you do a shot of where exactly you're clamping on assembled shears?
I'm going to take it off my angle here. The blade that you're not sharpening, I pull tight against my clamp. Okay, I don't have it loose where it can move around. I've got it pulled tight up against the front part of my clamp. It's all the way down in the bottom. I'm going to tighten, lock in on the outside of the clamp, just like as if the shear was unassembled. I'm still clamping in the exact same position. Okay, I want to try and make sure that the profile of my cutting edge is as parallel as possible with my arm, but this is where I'm clamping. With the shear still assembled, be very careful. I'm going to set my clamp back to 35 again. Be very careful when you're setting the shear down on the plate that you don't touch the opposite blade to the outside edge, because that's just going to create a little tiny notch in your cutting edge, and you're going to be mad at yourself. Ask me, I know.
We had a question coming in an email that's similar to this,
Okay.
asking when you would or wouldn't disassemble the shear.
I do not disassemble standard bevel shears. You have to disassemble convex and semi-convex. The reason you have to disassemble those is because you are working the inside line. The inside line goes all the way. Let's cover this again. I'm going to take this shear out so I can use both hands safely. Your inside line goes all the way down your cutting edge, and then it becomes the ride area. So when you take a shear, or when you have a semi-convex or convex shear, you have to work the whole ride area and inside line. All of this area you have to hone. You can't hone this if the shear is assembled. You just can't. So that's my differentiation, is if it's got an inside line I've got to work, you have to take it apart to do it. If it's just a standard bevel shear, you don't have to take it apart.
I got another one about that. What if you have a spring? Do you have to take them apart?
A spring on your tension system, that's typically a sign of a semi-convex shear. Most of your standard bevel shears are going to be split screw, tapered screw, screw and nut. I mean, it's not meant to be taken apart. Your tapered screws are typically a one-time use type of application where the screw is being deformed into a tapered thread, and that's what's supposed to keep it from loosening up. If you remove that screw and then you run it back into that same hole, there's no resistance to keep that screw in place. That's when you have to use a Loctite or deform the threads, which you really don't want to do. But that's another one of the reasons why we don't want to disassemble a standard bevel shear.
Okay, while we have that, can you clamp? So he has a follow-up question. Can you clamp onto the tension spring?
You really don't want to. That tension spring is, and I'm going to take a shear here. Where did that convex blade go? There it is. Make sure this is, yep. All right, I've got a shear here that has a tension spring, and I'm going to put it together real quick, okay? Because a picture is worth 1,000 words. This is not the blade for that. This one is. If I was going to clamp this shear in like this, I'm going to be clamping on my spring. In order to get enough tension to hold this shear in place, I'm going to have to tighten this down so much that I'm going to deform that spring. If you crush it, you bend it in the wrong direction, it's no longer going to perform as it's supposed to. It's no longer going to keep this nut locked into place because you flatten it out and there's no tension for that. So if you've got a spring on your shear, it is most likely, I would be very, very sure and confident to tell you, if there's a spring there, you've got to take it apart to sharpen it, because you've got an inside line that needs to be worked.
While Glen takes that scissor apart, I just wanted to touch, Z-Bars asked the difference between semi-convex and convex, and thank you, Bill, for answering it. But I just wanted to note, if you go back to the video on the Okami Gold and convexing, I believe it was last week, we show the macro shot. We show the difference between convex and semi-convex up real close in the macro shot. I'm not sure when it is in the video, but if you can kind of scroll through and should be able to see that part on that.
We've also got, if there's coloring on the shear, there's a bevel. It's a polished bevel. Polished bevel and semi-convex are the same thing. So if you have coloring on the shear, you've got a semi-convex edge. Where this is the convex that we just sharpened, if there's no coloring, look for a very distinct shoulder, or you can look right in the entry and you will see more of a defined bevel. But yeah, if you can't see a distinct shoulder, you've got a convex shear. But thank you, Bill, for covering that. That goes here and that goes here. If there are no more questions,
I think we're good to move on to the next.
All right. The next topic is working the ramp on thinners. I know we talked about that last week. Was it last week?
I think it may have been
2 weeks ago?
several weeks.
All right.
Days ago, yeah.
So this is one of those topics where you know just enough to be dangerous. So I'm going to try real hard to show you examples of what you want it to be. And then I've got a couple examples of I took the ramp out of one set of thinners and I overextended the ramp on one set of thinners. So hopefully we're able to get some real good pictures of that. Caleb has done an excellent job in getting these cameras set up just right. Now, I've got the Okami Gold deburr block, and I also have a whetstone. And I'm going to show you how the process would be worked out on both of them. So, what we were looking at here initially is a thinner. We can see a very aggressive tooth pattern. There's your inside line right there. Okay? There's your inside line, and it's on a flat plane. If I rotate this a little bit more towards the light, we will see the ramp right there. At the tip of each tooth. Come on, Glen. There we go. I gotta get, there's your ramp. And that's the tip, just the very, very small tip of each tooth. Okay, there's your inside line. There's your ramp. So you can see it wouldn't take much to remove that. If you remove that ramp, then your solid blade is going to be hitting into the edge of every single tooth. That ramp has to be there. But if it extends too far, then you've lost the use of your notches. Okay, here's another blade. This one does not have any, there we go. This one does not have any notches, but it still has a ramp. Let me find your inside line right there. And there's your ramp on every tooth. Ramp, inside line. Here's another blade with very thin, very small notches. There's your inside line. Now, notice the ramp is on the tip of each notch. All right, it's good. So there's your ramp. There's your inside line. Okay? This next example is an inside line. I've seen this and I've done it myself, where you want to clean up the teeth. Okay, that's the intended purpose. You want to clean up the teeth. So you run it a little bit on your whetstone and inadvertently you have removed the ramp. That inside line goes all the way up through the teeth. Now you've run into a problem of it banging against each tooth. So you do the old spread to close, press to open. You drag the other blade across each one of those tips of the teeth. Now what will end up happening is you're going to be pinching periodically or at somewhere along these teeth. Get my nasty old thumb out of the way. So spreading to close, pressing to open isn't going to fix this problem. Okay, I'm going to show you how to fix that. This, hopefully you can see, is an example of the ramp that extends too far.
Oh, going the wrong way.
There we go. The ramp right there extends past the notch. There's your inside line. There's your ramp. And it has extended too far. So we're going to fix both of these problems. All right.
And a question come in
Go ahead.
asking, so what you're saying is the ramp has nothing to do with cutting the hair.
The ramp has... That's a good question. Does the ramp have anything to do with cutting the hair? If the ramp extends too far down the tooth, it will prevent you from cutting hair. It'll pinch on every single tooth. So yes, the ramp has something to do with cutting hair. But if the ramp isn't there, then it's going to cause a mechanical problem, not a hair cutting problem. So the ramp provides mechanical work. I'm missing a word here in my head. The ramp's got to be there for the shear to work mechanically, but it can't be too much where it's going to cause it problems from cutting hair. Okay. This is the shear. Let's see. This one.
I can jump back
All
and
right.
forth.
No, this we'll let's see. Why don't we go with, well, no, we got to do this. So can you go ahead and, we're going to need some angles, so we're going to get tight with this one here.
Yeah. Here we go.
All right. That ramp is only going to be about 2 to 5 degrees off your plane. So in other words, you want just 2 to 5 degrees angle. You're not going to come up like this. You want, and then hopefully, how do you know whether or not you're 2 to 5 degrees? I don't know. Practice, work on it. It doesn't have to be exact, but you don't want something real aggressive like this. Can you see that all right? Oh, excellent. Okay. So all I'm going to do this year, what I did is I worked this blade on the 6000 grit until the ramp was completely gone. On this particular shear, I've got little teeny tiny notches. So I've got to be real careful I don't extend my ramp past those notches. And it's going to be, there's my 2 or so degrees. All right, let's take a look at it on this one.
Okay.
There's my inside line, and there's the start of my ramp. Okay, I can go a little bit farther. Let's see if I can get that a little bit better. Go ahead and leave this one on.
Okay.
We've got overhead on this, Dan?
Yeah.
Okay. All right.
Get that focus. There we go.
And there's my ramp. Now, I like that. So obviously, to rework an inside line on a thinner that the ramp has been removed or you had to sharpen some damage out of the teeth, you're going to need some good light and a good magnifying glass or a loupe, a jeweler's loupe, or they make some great microscope attachments for the smartphones, something that's going to help you see what you've done. The other challenge is the profile on this shear is fairly straight. Well, what if I was working with this shear where the profile is arced? I'd have to be very careful to make sure I've got this full arc properly ramped, and I don't over ramp one set of teeth to where it causes it to pinch hair and under ramp or put no ramp back on the tips. So this is going to be more challenging. It's going to take you a little more time. This shear also, if you're not using a whetstone, can also be done on your honing block. Again, just 1 or 2 degrees. Can you see that well?
We can switch that one full screen there.
There you go. So here's, and all I'm doing is lifting up just a little tiny bit, okay? And I will pull back so that my blade isn't laying flat. It's up like this, and I'm just pulling back, okay? A slight tip and pull back. working on the deburr paper, it may take you a little longer. So just keep an eye on it so you don't extend the ramp past the notch. Okay. This particular shear has the ramp extending too far into the teeth, so it would pull hair. So I need to extend the right area back out to the notches. There we go. Now, I've got a little bit more to go. And just so you can see what I'm doing, I'm going to clean this real quick. Oh, thank you. Now, I don't know if you're able to see the pattern, but we'll go with it. Take your time. I'm real close. And I'm gonna say, I'm gonna stop right there. So let's go ahead and change cameras again. And we'll look at the So there's my renewed. I'm gonna get my other finger in here. There's my inside line, and I'm right at the bottom of my notches. So I could probably go a little bit farther. There's that excessive ramp, and I actually put that in with a 1000 grit whetstone, so I wanted it to be very excessive. So I could extend even farther so that less of that notch is ramped. You know, the two sides, there's nothing I have small enough to point at it, but each side of those notches, I could go farther with the work on the whetstone. We're good, Dan. Thank you. I hope that helps, guys, gals. This work is very advanced. It would be very good to get personal training, hands-on, where somebody can say, okay, yes, you're doing this right, or you're not doing this right. And I understand I haven't assembled shears, I haven't tested anything, I'm just showing the basics of the process. If you've tried to work inside lines or tried to do ramps, I hope this is helpful to you. And if there's any more questions, man, shoot them to us and we'll see what best we can to help.
Yeah, cool. So we thank you guys for hanging out with us. I'm gonna kind of let the comments run a little bit and the questions so that we've got time to answer. But John does have a question. How much pressure for the ramp? What are you doing there?
Very light. Again, you're talking about such a small area of contact on this stone, and you can do it wrong quickly. So lighter pressure. It's like sharpening on the twice as sharp. It's better to use light pressure and make more passes than try and get it done in one pass. So again, light pressure, more passes.
All right. We appreciate the feedback we're getting on the camera work and the lights. We try really hard to make sure we can see everything. It really helps what Glen's talking about. So we appreciate that feedback. We hope that we just get better as we go doing this. So I think we're good on questions. Let's see.
We're doing on time.
Tim, is there any simple way to do ramps on blades with arc?
No, there is no simple way. It's a matter of practice. I would suggest you go to the beauty store, buy a thinner with an arc on it, sharpen it off and put it back on, or work it on the inside line till it disappears, and then practice putting it on. That is the best advice I could give you.
All right. Appreciate the feedback, Tim. I hope that kind of answers your question after a couple weeks ago when we talked about the thinner ramps. I believe that's it that we've got going on here. So thank you again, guys, for sticking around with us and watching over the last 8 weeks. We will be announcing all the details and stuff for our monthly one soon, so be sure to follow us on Facebook. You can just search Wolff Industries, and we'll be putting most of our announcements there. We'll probably try and post in some of the sharpening chat groups on Facebook, Sharpeners Unite, Sharpeners Chat, that kind of thing. But the best way to make sure that you see it is to just check our Facebook page. We'll be sending out emails and stuff as well. But we'll be following those details out. It does look like we're going to be doing Mondays and maybe Monday mornings around 11 a.m. on Eastern. But we'll be sending all that information out to you guys as well. We want to say thank you. Continue to drop questions and topics that you would like to see in there, and we will try to address those on future videos. We're going to take our attention and kind of put some of our effort with this equipment into creating some formal training videos over the next little bit. And so hopefully we'll be seeing some of those coming out soon. Last little question here. Are all tooth shears supposed to have ramps?
Yes.
Yes.
Your thinner has to have a ramp in order for that opposing blade to pass from one tooth to the next. If you have a blade coming and it hits the side of one tooth, once it gets past that one, it's going to fall into that gap and it's going to hit the edge of the next tooth and get past that and fall to the edge of the next tooth and so on down the blade. So each one of those teeth has to have a ramp to allow the blade to smoothly pass and still get the haircut.
Very good. Cool. I think that wraps us up on questions. I do see Bill's dropping in some of the information with the next live stream, Monday, June 29th. The day before my birthday. So if you guys want to drop some happy birthday in the comments, that'd be great. Very good. Thank you. Follow us on Facebook and we'll keep you updated on the next one. Thanks, Glen.
Thanks for watching, guys. Gals.